Hello everyone, this is Ms. Cromwell, and I'm going over this week's homework. Um, this week's math homework is primarily going over just like a good review for our upcoming 13 and a half week assessment. However, I know in the newsletter I said that assessment is on Wednesday, but I was mistaken. That assessment is actually on Thursday. So I do apologize. I also want to apologize for my voice. I have laryngitis. I'm not sick. It's just a strain in my voice. So here we go. This one on the side, it says directions. Select all the correct answers. Some students created a model to solve the fact 2 times 4. Which students have a correct model? Circle the correct models. Let me zoom into this a little bit. So your student is probably going to see multiples of these on their upcoming tests. And it is very, very important that your student looks at every single option. Because this type of question is called a TEI. I forgot what all the numbers or the letters stand for. But those type of questions, the students have to interact with it. And if they choose most of them, but then they forget one, they still get the answer wrong. So they do have to complete or answer all the correct answers. So right here, student A, this right here, your student should automatically be able to say that this is not an option. This is not a model. And if you ask them why, they need to tell you it's because the array is not complete. Okay, arrays are equal. There's never an incomplete array. So no matter what, it's not this one. So slash and trash. I'm just going to draw an X. All right, student B. Well, I have one group, two groups. All right, so I got that. And then a 4. 1, 2, 3, 4. 1, 2, 3, 4. So student B does have a correct model for 2 times 4. All right, let's look at student C. Well, I can see that if we go from 0 to 2, that is 2 in the hop. So we got a 2. But what about 4? Well, this only has 1 hop, 2 hops, 3 hops. So this is not an accurate model. Student D there's 1 group, 2 groups, 3 groups, which 3 is not up here at all. There are 2 in each group, but it's not, this is 2 times 3, not 2 times 4. So this is also not a correct model. Student E, well, this is an array, so there are 2 down, 1, 2. How many across? 1, 2, 3, 4. Is it a complete array? Yes, they all have the same in each row. So yes, this is also a correct model. Student F, we go to 0 to 2 on our number line. That is 2 inside of each hop. So again, we have the 2. How many hops? Well, we have 1, 2, 3, 4. Ooh, well, that says 2 times 4. So yes, this is also a correct model. Students will have to make sure that they complete or select all 3 of those in order to get it correct. All right. Then on this side, we have the same type of question. We wanted to give lots of extra practice. But this one is 3 times 4. So again, we are circling the correct models. So again, on here, this should be a no-brainer that this is an absolute no. For this first fact, it's not a complete array. But also, it doesn't have 3 down or 4 down or 3 or 4 across. So this is a no. Student B. All right, well, we have 1, 2, 3, 4 groups. So we got a 4. But inside, there's 2 in each. And the other number that we need is 3. So this is not a complete or a correct model. Student C. We have 1. It's kind of hard to see on here, but this is a group. They're in rectangles. So that is 1, 2, and 3 groups. And inside each group, you have 1, 2, 3, 4 triangles. So yes, this is an accurate and a correct model. All right. Next is another number line. So we go 0 to 4. Well, that's 4 inside each hop. So the 4 checks out. And then there's 1, 2, 3 hops. There's your 3. So yes, this is a correct model. Next, we have another array. It is all equal. It is filled in. So all of these rows have the same amount. How many down? 1, 2, 3. How many across? 1, 2, 3, 4. Perfect. So that's 3 times 4, which is what we're looking for. So yes, that is also an accurate or correct model. And then this one on this side, student E. We have another number line. We go from 0 to 3. So, okay, we have 3 in each hop. So the 3 would check out. But there's only 1, 2, 3 hops, not 4. So this is not a correct model. All right, let's go down to the side. The graph below shows the number of different shirts in Cassie's closet. So make sure your student remembers with graphs, we need TLC. Does it have a title? Yes. Does it have labels? So your number of shirts, or the number of shirts and shirt colors? Yes. Does it have categories? Which are these? The yellow, green, blue, and white? Yes. Perfect. Now when you look at the question, according to the graph, how many shirts are there in Cassie's closet? So students will have to read this bar graph. So yellow has 7. Green, come up here, it has 6. Blue has 3. And white has 2. Students need to know that we need to add because we want to know how many total are in her closet. So we're going to add 7 plus 6 plus 3 and 2. Students can either choose to break it apart and do 2 at a time or all 4. I'm just going to do all 4 because of time. So 7 plus 6 is 13. 13 plus 3 is 16. And 16 plus 2 is 18. So A is your answer. And yes, your student needs show work. All right. Our next one over here is a multi-step word problem. These have been pretty tough for the majority of our students. So just please work with your students. Make sure they're reading and ask questions while you're working on them. This specific question says, a truck driver drove a total of 798 miles and stopped at 3 places. He traveled 231 miles to his first stop. From the first stop to the second stop, he then traveled 253 miles. How many miles did he have left to travel to get to the third stop? So when I was teaching this originally, I taught students, make your box. And it goes straight down the middle. Okay? Your top box is always the total. Always. Your bottom box gets split apart. And you know how many parts go in here based on how many numbers are in your problem. So how many numbers are in our word problem? We have 3. We have 798, 231, and 253. So since there are 3 numbers in our word problem, this bottom box gets broken into 3 different spots. Okay? Next question to ask your student. Do we know the total number of miles? The answer is yes. It says it right here. The driver drove a total of 798. So your total would go up here. Now these other numbers go down here. Doesn't matter which box. But what I've told students that all 3 of these numbers will always add up to whatever number is on top. If you get a different number, you did something wrong. Okay? So we have 231. We have 253. And then we don't know what goes there. So this problem can be solved many ways. Students can take the total and then subtract each of those from it. Or students can add these numbers and then subtract it from this. Some students have a hard time with all that. So they just add those and then go through and add each of these and figure out which one equals 798. Any of those options work. We just need to have show work. Okay, so I like to subtract twice for the simple fact that I know a lot of students get confused between the adding and the subtracting and what goes where. So I'm going to do 798. I'm going to subtract this first number, which was 231. I know it's hard to see. So subtract 231. We start in the ones place. 8 minus 1 is 7. 9 minus 3 is 6. 7 minus 2 is 5. Okay, so we done this one. Now we got to do this number. So again, we're going to subtract 253. So, oops, I'm going to put it over here. We're going to take this number, 567 minus 253. Oops. 7 minus 3 is 4. 6 minus 5 is 1. 5 minus 2 is 3. So 314 miles. All right, let's see. Let's do the one right underneath. Okay, so this first question, the first thing we need to look at is which of these is best represented by this number line. So this can be a few different things. We know that, let me see if I can zoom in because I don't know if you can see it well. But if you were looking at this number line, okay, I want students to always look at which direction the arrows go in. So if the students are paying attention, this line, there's an arrow right there, right? There's a line, arrow. There's a line, arrow. There's a line, arrow. So ask your student, which way is the arrow going? Well, it's going towards the 0. So I told students when we were learning this that if it's going towards the 0, you are always dividing. Always. Okay? If the arrow was going the opposite direction, you would be multiplying. Okay? So since we're going backwards, we know we're dividing. If we're looking right here, our only two options, we have minus, division. Minus and division. So since the arrows are going backwards, I know for a fact it is division. So both of these subtractions are slash and trash. It cannot be that whatsoever. Okay? The students also know that with division, order does matter and that the largest number always goes first. So luckily all of these already have the largest number, which is 12. Okay? So we know 12. Now, we have multiple options, okay? We could, 12 and then divide it by the 3 hops. However, 3 is not either of these numbers. We only have 8 or 4. So counting the hops is not going to be helpful. However, this is when we go down and we count each tick. So 12 to 11, 1. 11 to 10, 2. 10 to 9, 3. 9 to 8, 4. So how many are within each hop? There's 4. And that is that number right there. So D is going to be your answer. Okay? Let's see. Oops, sorry. I'm trying to move this down. I forgot that I zoomed in. I apologize. All right. Next question. John has 16 tomatoes. He wants to divide the tomatoes among 8 neighbors. How many tomatoes will each neighbor get? So this one's very helpful because it tells you that you're dividing. It does not always do that. Okay? So we want to divide. So we know that 16 is going to be our largest number because students have been told and learned that division, the largest number will go first, at least in 3rd grade. So we know we have 16 tomatoes, and then we have 8 neighbors. So I would ask students to make 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. All right, I've got my 8 neighbors. Now I need to give each of them You got to split up my 16 tomatoes. So I'm going to go through. Let me change my pen color. And each one gets 1 tomato because we want them equal. Okay. And then we got to stop at 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, I stopped at 16 because that's how many tomatoes. And how many did each of my neighbors get? 1, 2. So D is my answer. All right, down here, oops. All right, it says correctly. This was a really hard skill, by the way. So make sure that your student is using the strategies. Correctly place the 2 numbers that are less than, so it'll look like that, and greater than the number represented by the blocks. So the number 1 step, we need students to figure out what number is represented, okay? These are cubes. Students should know that this is the thousands place. So how many thousands? We have 1, we have 2. So 2,000. Do we have any hundreds? Yep, we have 1, 2, 3 flats. So we put a 3 in the hundred spot because these flats represent 100. Next we have rods, which represents tens. So in the 10 spot, we have 1, 2, 3, 4. And do we have any ones? 1, 2, 3, 4, 5. Okay, so 2,345. You will notice that the number being represented is typically always going to be an option because so many students want to count and just assume that that number is going to go here. That's why we need the students to slow down and read. Unfortunately, in 3rd grade, teachers are not able to read to students at all. We cannot help. We cannot answer questions. So if we know that this number being represented is 2,345, I need to figure out which one is less than. So what I'm going to do is I'm going to stack them. Okay, so I already used that number, so I don't need it. So I'm left with 2. So 2,345 is this number. I'm going to put 2,178, 2,178. Starting that thousands place, 2 and 2, same or different? They're the same. Hundreds place, 3 and 1, same or different? They're different. All right, well, which one's less? Ooh, there's 1. So this number, the 2,178, would go here. I always like students to double check because it is so easy to make a mistake. So again, you'd come over and you would just double check. So your 2,345, which was the number being represented. And we're going to use our other number, 2,402. And again, this side we're looking for greater than. 2 and 2, same or different? They're the same. Go to your hundred spot. 3 and 4, same or different? They're different. Which one is greater than? Oh, that's the 4. So we're going to put it up here, 2,402. Okay. This type of problem, these 3 numbers at the bottom, students would have to click and drag it on the computer to where it goes. Students are still responsible for showing show work on their scratch paper. All right, so that was Monday. Apparently I copied it too many times. So, all right, here we go. Let me make this zoom out. There we go. So Tuesday, we got another one of those TEI questions. And this one says to identify each model that shows 3 times 4. Okay. So look at this one. We have 1 group, 2 groups, 3 groups. That's the 3. How many is in each group? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So yes, this one does represent. So students would need to click it if it was on a computer. Okay, in a circle. All right, over here we have 1 group, 2 groups. No, that's not right because there's not a 2 in neither of my factors are 2. Also, your student should automatically be like, that can't even be an option because equal groups have to be the same amount. This group has 1, 2, 3, but this group has 4. 1, 2, 3, 4. So this could not be an option. On this array, we have 1, 2, 3 going down, and we have 1, 2, 3, 4 going across. It is completely filled in. So yes, it gives me my 3, and it gives me my 4. So this, yes, can be an option. It is an answer, okay? Your direction says to select all the correct answers. So if your student does not choose all of the correct ones, they will have it wrong, okay? This side, students should already be able to say, nope, it cannot be this. It is not filled up correctly, okay? It cannot even be it. If they're not paying attention, don't realize that, we should have 3 going down. We only have 2, okay? Maybe they didn't realize, they see the 4. Yes, there is 4 this way, but then you would still need a 3 going down. So, and it's not, again, it's not completed. So it cannot be that one. The number line, okay, we want 3 times 4. Well, again, you have multiple options. You could count the hops. 1, 2, 3, 4. We see that the arrows are going away from the 0, so it is multiplication. However, if you look on your number line, we go to 0 and we go to 2, which means there's only 1, 2. There's only 2 inside each hop, not the 3. So this cannot be an option. Lastly, we have this one. Again, my arrows are moving away from the 0. I can see that there's 3 inside each hop. Okay, there's 1, 2, 3. It even numbered it on top of us up there for us. So that was nice. Okay, so each one has 3 inside each hop. So that's this number. How many hops do we have? We have 1, 2, 3, 4 hops, which is this. So yes, that is also a correct answer. So students would need to have all 4 of these to get this specific type of question correct. All right. So on this one, Miss Hester placed 24 pencils into 4 equal-sized groups. So I asked typically, so like right now, hold on. Right now you can see the lines. Sometimes it's not like that, okay? But this type of question or this specific question, they do already have the group. So you can see that there's a total of 24 pencils. And you can see that we had 4 equal-sized groups. So students should be able to just already know that 24 is going to be divided because it tells us that she placed those into 4 groups. My question is, which of the following equations best represents this solution or situation? So if your student did not realize that we're dividing, right? Maybe they just, I don't know, wasn't paying attention, didn't read it. A lot of our kids just don't feel like reading. They know your student should be able to realize at this point that their equation has to have both of these numbers. It has to have a 24 and it has to have the 4. Okay? So if I look at A, it has a 4, but then it has a 5 and a 20. Where's the 24? So it cannot be that at all. This one has the 24. That one has the 4. And we're dividing. So I'm going to leave it. I always tell the students, do not ever go to the first one that sounds right. Because it oftentimes tells you to find the best that best represents. So while one may seem well, sometimes there's one that fits better. I look at C. Well, this has a 6, and a 36. That's neither of these. There's no 6. There's no 36. So again, C cannot be option. 24, right? D says 24 plus 4 is 28. So yes, it has a 24. Yes, it has a 4. But we're not adding, okay? It tells us that she placed them into 4 equal-sized groups. So if your student chooses this, it's just because most students are much more familiar with addition and subtraction. However, this specific problem is looking for division. So B would be your answer. All right. Another way of knowing, just count how many pencils are in each group. 1, 2, 3, 4, 5, 6 is in each group. So some students are going to want to just draw the fact family. They know that the total is 24. They know that 4 is one of our numbers. And then if they counted and saw that there's 6 pencils inside each group, then 6 would go here. And this is also show work because 4 times 6 is 24. 24 divided by 6 is 4. 24 divided by 4 is 6. Okay. This one over here, we have 2 different ones. I lied. It's not 2. It's the same one. Sorry. Use the numbers to the side to create 3 related facts connected to the model above. Yes, it is given on a number line, but then it gives you the entire problem. Your student should be able to automatically know and tell that their fact family can only have those 2. So for every single multiplication fact or fact family, there's always 2 multiplication facts and 2 division. So if we already had 8 times 2 equals 16, then 2 times 8 is also 16. And then we have division. Again, the largest number always comes first, at least in 3rd grade. So 16, and it doesn't matter which one goes first. So 16, I'll do it, divided by 2 is 8, and then 16 divided by 8 is 2. And a great way of show work, again, is just your fact family where they can put 16, 8, and 2. All right, over here. All right, Frankie has 18 Skittles and plans to put them equally into cups. Select all the possible ways that Frankie can arrange the Skittles into cups. For this one, I just tell students to go through each one and show work for every single one. So this top one says 2 cups of 8 Skittles. So if I had 2 cups, 1, 2, and if I put 8 in each side, I'm going to zoom in real quick. Maybe I zoomed in too much. Sorry about that. All right. All right. So we had our 2 cups, and let's put 8 Skittles in each. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Let's count. Do we have 18 Skittles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is 16 the same as 18? No. So that cannot be your answer. Okay. Next one. 2 cups of 9 Skittles. 1 cup, 2 cups. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's add them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is 18 equal to 18? Yes. So that's going to be one of them. Okay. They're going to do that for each of these. So 3 cups of 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if they counted these, 5, 10, 15. Is 15 equal to 18? No. Okay, 3 cups of 6. 1, 2, 3 cups. Move that up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If we added these up, we would have 6, 12, 18. It is perfectly fine for the students to just count them for time purposes. I was just trying to speed along. So is 18 equal to 18? Yes. So this one is also an option, an answer choice, sorry. Last, we have 18 cups of 2 Skittles. Okay. If they did this, that means that they are multiplying 18 times 2. Some students are going to be able to realize that and be like, that there's no way that's an option because that means that we're multiplying 18 times 2 when our problem says that he only has 18 Skittles. So If they choose to do 18 cups and put 2 in each and then count them all, okay, they'll get 36. But hopefully students are starting to get comfortable enough to realize, like, there's just no way that's going to work. Now, if it's at 18 cups of 1 Skittle, then yes. But 2 Skittles, no. So that would also be a slash and trash. And, all right, here we go. Wednesday. Hudson created a model to solve for 6 times 2. I told students when we were learning this to look at this. When they see this type of problem with the dotted lines, that means that we are assessing their knowledge on the distributive property of multiplication. Okay? So because of that, and you see the dotted line, your student needs to ask themselves, all right, is it the exact same on both sides? Yes, it is. There's 6 on the side, 1, 2, 3, 4, 5, 6. And there's 6 on the side, 1, 2, 3, 4, 5, 6. So because of that, you know that your answer is going to be he doubled. Okay, so if these are the same, you will automatically know that it is doubled. Okay, as far as the other one that could possibly an option would be broke apart. Okay, so that is your only other option. Well, most of these are, like C is a true statement, D is a true statement, but we're talking about what is being shown in the model. So this one is doubled, and it's because this dotted line is showing the distributive property, multiplication, and since both sides are the exact same, he doubled. That's just the easiest way I have found to explain it to the students until their brains, develop more and can understand it at a higher level of thinking. All right, down here, complete each of the following equations by writing a number in the box, which makes the equation true. All right, so we just have to figure it out. The students typically do better with the ones where it says equal, but sometimes not. So 15 divided by 5, I just usually have students just do the equal groups. 1, 2, 3, 4, 5, and then put 1 in each group until we get to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many is in each group? 1, 2, 3. And they all should have 3, so 3 would go in this box. Okay? 6 times blank equals 24. Well, again, if I have 6 groups, 1, 2, 3, 4, 5, 6, I'm going to just put 1 in each one until I get to 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, I got 24. I'm going to stop. How many is in each one? 1, 2, 3, 4. So that goes there. Okay. 36 divided by 9. Again, make your 9 groups. 1, 2, 3, 4, 5, 6, 7. Oops, you can't see my paper. 7, 8, 9. And now I'm going to count 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. How many is in each one? 1, 2, 3, 4. So 4 just so happens to be that number again. All right, over here is the exact same thing, okay? Just kidding. It's not. Very similar. I apologize. Getting tired. In 5 days, Food Lion sold 35 gallons of milk. the same number was sold each day. Which equation shows a way to find the number of gallons of milk the store sold each day? So we know that 5 is going to be involved. We know that 35 gallons of milk were sold in one day. So we want to figure out. Oh, hold on. Sorry. It's not each. Apparently, I need more sleep. I am so sorry. So we had 5 days. Within those 5 days, 35 gallons of milk were sold. The same number was sold each day. So we know it's going to be equal groups. Oops, I apologize. Just dropped my phone. A great way to do this is going to be, yes, students can do a fact family. That's a very easy one for them to do. But also putting, 5 groups, 1, 2, 3, 4, 5, and then separating them until they get to 35. Some of the different strategies that I'm trying to teach students is work smarter, not harder. Okay. If you look at A, it says 5 divided by blank equals 35. I'm trying to tell students, for a fact that if you are dividing, you're not getting a bigger number. Division means you are breaking it apart. So there is no way that A could be correct, because a 5, if you're breaking a 5 apart, there's no way it's getting bigger. Okay? So A is not going to be right. Right? Now, I do understand as they get older in middle school and whatnot, rules change a little bit, especially if this is like a decimal. But as far as 3rd grade, no. All right. Next, B says 5 times 35 equals blank. The only way for this one to be even logical is if students don't realize that they're dividing. Because we're trying to figure out how many gallons were sold each day. We already have a total. So if the blank is over here, that means we're looking for a total. So this is not going to be an option either. C, same thing. Blank divided by 35 is 7. Well, we know the total is 35. So if we have 35 and 7, that means that 5 would have to go here, and 5 divided by 35 is definitely not 7. Okay, so without even figuring out too much, this alone is going to be your option. Some students have learned to count by 5s. So, 5, 10, 15, 20, 25, 30, 35. Well, how many times did you count by 5s? 1, 2, 3, 4, 5, 6, 7. So, 7 would go here. If they chose to do this fact family, they would know 35 and then 5 and 7. Lots of options. They could also, at the bottom when I did the 5 groups, they could go through and, 1, 2, 3, 4, 5, all the way to 35. And then 7 would be in each side or in each group. So there's a lot of different ways they could solve it without exerting too much energy. But at the end of the day, if the students are not reading the problem, it's going to be kind of tough to figure the rest of this out. All right. Let's see. Hold on. Which shows the expanded form for the number 607,530. My favorite way of doing this is having the students on their show work paper write the number. So 607,530, and then go by each digit. So write 6, and then all of these become zeros. So if I have a 6, that means I'm going to have 1, 2, 3, 4, 5 zeros. Well, here's a 6, but 1, 2, 3, 4 zeros. Not it. A 6, 1, 2, 3, 4, 5 zeros. Okay, maybe. 6, 1, 2, 3, 4 zeros. Nope. A 6, 1, 2, 3, 4, 5 zeros. All right, also a maybe. There's nothing in the 10,000s. So I go to my thousands. There's a 7. Again, both of the rest comes to zeros. So I have a 7 and 1, 2, 3 zeros. 7 and 1, 2, 3 zeros. All right, that works. But up here is a 7 and 1, 2, 3, 4 zeros. So automatically, you should know that's not it. Students might not realize, but they could do the same thing. You know, bring the 5, rest zeros, a 3, bring the 0, and then add them together. So, oops, sorry, can't see. 600,000 plus 7,000 plus 500 plus 3. Just kidding, 30. Very sorry. So, but C is going to be your answer. All right, last math. Sorry, trying to whiz through real quick. Right here, a model of 2 different numbers is shown in the box. Which symbol correctly compares the models in the box? So students just have to write or add up these base 10 models. So your flat is worth 100. So there's 100. 1, 2, 3, 4 of the rods, which is 10s. So 4, and then how many units? 1, 2, 3, 4, 5, 6. So this number on this side represents 146. All right, over here, we've got 100. We've got 1, 2, 3 rods. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully students are like, oh my goodness, that's another 10. And that students are going to want to circle it and add 1 more. So 3 plus 1. And so above it, I'm going to put 4. And then how many of these? 1, 2, 3, 4, 5, 6. So 146. I have 146. 146. What is it? They are equal. Okay? Some students don't realize that the circle is there to make another group. So they might have, the 100, the 3 rods, and then when they're counting, the 10, 11, 12, 13, 14, 15, and then 16. So they might do something like 100 plus 10, 20, 30 plus 16 units, and then 0, 0, and 6 is 6, 0, 3, and 1 is 4. 1 plus nothing and nothing is still 1. So regardless, whichever method, you get the same answer. Daniel spent $45 and John spent $19. Which strategy gives the closest estimate for how much more money Daniel spent than John? Number one thing for students to do, just solve it because it's going to be the easiest. Okay? So 45 minus 19. Okay? If I have 5 and I subtract 9, well, you can't. You got to borrow. They don't have enough. So that 4 would become a 3, and that 5 would become a 15. 15 minus 9 is 6. 3 minus 1 is 2. So 26 is your answer. Which of these numbers is closest to 26? You have 30, 25, 20, and 35. So this is going to be your closest. In 3rd grade, we learned 3 different estimation strategies. This specific strategy, the 45 minus 20, is called comparable numbers, which means that we just like things that are easy numbers, like 5s and 0s. So that's why B is written like that. All right, over here, it says place the correct symbol in the box to make the equation true. So this is just more of equality. Students just need to solve each side. So 145 plus 3, we do want students showing work. So, 145 plus 3, 5 plus 3 is 8, 4 plus nothing is 4, 1 plus nothing is 1. So this side is 148. Over here we have 145 minus 3. 5 minus 3 is 2, 4 minus nothing is 4, 1 minus nothing is still 1. So we have 142. All right? So 148, 142. So now the students have to figure out which symbol would go here. Well, which one's bigger? That's my favorite. Well, the 148 is bigger. So that is where my alligator is going to eat. Okay? So students are going to do this for all of them with their show work. for that one. On the computer, these are little symbols, and they would just click these and drag it. We tell students to make sure they're slowing down so they don't accidentally put it in the wrong one. And then the last type of problem is just our standard subtraction. However, please remind your students that they need to stack. If they're like, oh, I can do it with it next to each other, you cannot. Just trust me. I've been teaching third grade long enough. And while occasionally, sometimes students can figure it out, 9.5 times out of 10, they cannot. So please just tell them to just take the time and do the work. So if we stack it, in our ones is where we start. We have 6 minus 4, which is 2. And our tens, we have a 3. But can I take away 5? No. So I have to borrow. That 9 becomes an 8. The 3 becomes a 13. 13 minus 5 will be 8. Yes. Sorry, I was trying to do the math. Is 8. And then 8 minus 4 is 4. So 482. And I believe that is all of our math homework. If anybody has any questions as far as our ELA reading homework, reach out. I don't mind making a video for that, but I just know that the videos were getting long. So I did not continue to make those. Any questions or concerns, please reach out to either Miss F or myself. Have a great evening.